You know, there's a lot of things, a lot of projects that need a PID controller. PID controller is a proportional, integral, and derivative, and you give it a certain set point, and the mathematics and the numbers try to do whatever it takes to keep that number at a stable set point. Now, I know that some people use them for like soldering iron projects to keep the heat temperatures right. Some people use them for, you know, little toys like this. This is a balancing arm. And you need the PID controller so that it balances right there, but it doesn't overshoot and it doesn't take too long to get. So if you touch it, it jumps right back to where it's supposed to be. You know, that's another reason. Or maybe you've got, you know, like a cool robot you've been working on forever. You know, this is the old model of Cutesy One. You know, he's kind of old now. He's been around for a while. He's been through some changes. You know, this is what the updated version is beginning to look like right there. So he's got suspension, you know, so he can drop them. He's got some kind of give. You know, he's a good, decent balancing robot. But the problem is, when you're working on something like this, or this, or building an Arduino quadcopter, or a hexapod, or any kind of control system that you need to try and keep a variable the same, you gotta tune the PID. And this can be hell. In like, I know for Cutesy here, it was hell, and there was a lot of times I just wanted to take him, rip his fucking arms off, you know, and throw him off to the side because he pissed me off, and there was nothing I could do to try and get it right. So the long version was you had to check it and then update the program, reload it, and blah, blah, blah. Now with Visuino, sometimes that was even harder because it took longer sometimes to load the sketch, or trying to figure out a new way to work with the PID, and you're not used to how it works. So this is the PID tuning tool. What it allows you to do is it uses the EEPROM and a nano. It uses the inputs from the keyboard. It uses a bunch of different variables to help you find a basic starting point for your project. Now this will work for anything, like I was saying, soldering iron project, a balancing robot, you know, all kinds of stuff. You don't have to tear your robot apart because you can't tune the PID. Let's give this a shot, and I'm going to show you how it works. Okay, just so you know how hard this is, I had to make notes, and I drew a picture. Anyway, so for this test, we're going to be using this balancing arm. What it is basically is you set a set point where the arm is level. It has a 3S battery. I'm going to go over the hardware here in a second with a picture so you can see it. But basically the goal is to get the set point so it's level, and then tune the PID so that it hovers there, and, you know, hovers within reason, you know, maybe not perfect off the first bat, but within an inch, half inch each way, quarter inch each way, you know, so it'll just a little bit hover up and down. That would be perfect. But let me go over the hardware and show you what this is set up, blade pitch, all that crap. So let's get that done first. Make sure you're smart. Make sure you got your eye protection on, you know. If you got your hearing protection on, if you've got a loud old lady that's bitching at you for working on the stuff, if you have a lithium polymer power source, make sure you got a lithium polymer protection bag, and only charge it the correct way. Do not discharge it too much, so be safe. So I'm going to go over what hardware I'm using and what I had to do to get it tuned in. First of all, with the BLDC electronic speed controller, the stock pulse width allowed was 544 to 2044. in Visuino, I had to change the stock servo pulse width to 2000 of max, 1000 minimum to get this motor to spin the right friggin' way. Come on, Jim, figure it out. But anyway, yours may differ. Number two, the mount I have here is mounted to the table. There's nothing right now to keep it from spinning over, but during testing I lost quite a few blades and a chunk of skin from it taking off and getting cut with the corner. This is a 2300 kV motor times 1.13S, 11.1 volts times 2300. That would be 23,025, right around 25,000 RPM. This thing can get spinning at, and it will do some damage. So be careful. The lithium polymer bag, watch out. Alright, let's go over what hardware I've got on here. First off, let me change the view for you. There you go. Now, this bar right here is nothing more than a rod from this little light fixture thing. All it does is it's this rod strap. It was broke, so I used it. What the hell? It's not going to bend. So that is that bar right here. The nano is right here in the center. USB, you see it. Now underneath this fancy white zip tie is some Velcro. Now sandwiched inside that Velcro is some double-sided white tape. Inside that double-sided white tape is the MPU 6050 gyroscope accelerometer strapped to the rod itself. I did that to keep the vibrations down. I was getting some vibrations from the fan when it kicked up, so we had to watch that. You see the lithium polymer battery. That's a 3S 2200 milliamp hour. At 25C, so 250 amps can come out of it. So be careful with that. Very careful with that. You can use a 7.4 volt 2S battery if you want to keep the blade speed down, or adjust it for yours. But if you change the battery, you're going to change all your PIDs. If you change the blade and the pitch on the blade, you're gonna have to change the PID again. If you mount the battery somewhere else, you're gonna have to change the PID again. So everything you change and do, make sure it's right the first time. Now over here is where the electronic speed controller is, and that is a 12 amp. Got it from Fly Sky, but it's a Heli Pro 12 amp. Single direction off a quadcopter. It was in a pretty good accident. It was on a 250 millimeter racing quadcopter. It is the clockwise rotation one, and that is all on that view. Now let me go to the next one here, and so you can see the overview, basically the props, and then the speed controller, the battery, the gyros over here, and then you see my next fancy notes up here. RM, capital M, little m, SPID, SPID. SPID is the word. SPID, 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 SPID. Okay, I'm down here. Peace. I have my safety glasses on. I will be taking the blade off when I start firing the motor up, just for safety purposes. You'll hear the motor, but I'm not going to take the chance of it fucking flying away or whatever. But anyway, I recommend you do the same. Now anyway, this is the basic overlay of the project. I have split it up into 7 different functions. You can almost see it as a flow of information as it comes in and goes through. Now, as far as the first section, that would be the Arduino Nano, and please notice up here I do have 4 EEPROM analog elements, and I name them PID, I, D, and S. Proportional, integral, derivative, and set point. So you can update those 4 elements. You may need to add more for your project. Who knows? Now the next section over here is obviously the PID controller. In this project, you have to enable the sync pins on the properties page in Visuino to get these additional input elements. Otherwise, this is where all the EEPROM reading comes into play, with all of that in the second portion here. Let's go to the next one, next section. So this is the first stop is the EEPROM, it gets that. And then the second stop is it looks at the PID. The third action that it takes is it gets the input from whatever you're testing. On this one, it's the gyroscope, and it takes it through the Kalman filter. It takes it through the analog mapping. It remaps it from a -1 into a +1 to a 0 to 1 scale, so that your PID can have a 0.5 center. Yours may differ. This one is 0.5 centered. And then over here is the BLDC. The BLDC would be the motor on the end of this deadly little friggin' stick here. So that is what that is. Now on to the next, so the fourth section. Let me go back, that sucked. I went one too far. So number 4 down here, this is, let me get my fucking notes, number 4. Serial input switching and routing. So when you type in a command, you connect with the serial monitor and you type in a letter, the different letters like S if you want to change the set point. If you enter an S, it's going to know you want to change it, but it's not going to remember what you had before. I have it set so it clears it and sets it to 0 when you press that letter if you have something there before. So if you need it, remember or write it down or whatever. Or you can look back in the serial at monitor window. So you put in your set point. Let's say your set point's 0.5. And then you press the letter S and then enter. And it switches here to the S section. Alright, over here. Here in the S. And then it toggles the S flop. Now that all of these are set up so that if you push S, the clock ping is not only going to set the S flop to a true, it's also going to hit reset on the other 4 so that they are turned to false. So you can't input, like if you push P and then enter a number and then I and enter a number, it turns off P. And then so that works with S, P, I, and D. Also M on and M off. Those are capital M and lowercase m. Motor on, motor off. That turns the actual BLDC motor on this, so you can turn it on and off. That's kind of a safety thing built in so that when you start it, it's not automatically on. It starts flying away and catches you by surprise, and that's how I chop my friggin' finger. So that's that area. Those are all the flip-flops. Next one up here, number 5. This is where it takes all of the system timers and clocks. 5, I have EEPROM and serial out timers and EEPROM update switching. Now the switching part right here, right in the center, right there where it says clock switch 1, 2, 3, and 4. That is what, when you push P, it sets this to be expecting a numerical input. Now that numerical input it triggers that clock switch, which comes over to the EEPROM right here on the remember portion, and it remembers that input, and then it stays on that letter, so you can keep putting numbers in. You don't have to push P, enter, and then a number, and then P, enter, and then a number. You can put a number after a number after a number. Like if you want to change your P, your proportional value from 1 and then to a 2 and then a 3 and then a 4, you can do that with 1 enter, 2 enter, 3 enter. You don't have to reset to 0 every time. So that's that section for the clock switching. Section number 6 here is where it actually takes the serial input formatting and EEPROM routing. So it takes the whatever signal you're taking in. For me, it is an analog signal from the gyro. Obviously, the analog switch is actually the numerical number that I'm inputting. So that comes, this analog switch comes from section 4 here, where the switching and stuff is done. Where number 4 is labeled as serial input switching and routing. Yeah, that's it. Yeah. So that's what number 6 does. Is it takes that routing information, it triggers the correct EEPROM switch from that pulse, and then it takes that information that you're inputting, that number, that's where that number comes in, is translated from the keyboard input to the numerical analog input, and that is fed up into the EEPROM up here on the in. Now, after that is fed up to there, all of the pins on the EEPROM on the Nano are set to recall on. Remember, I'm trying to get through this so quick. We're almost done. So that's number 6, where it updates the inputted value. Our next one is number 7 down here, and that is simply a toggle flip-flop, a not or nor, for formatted text. So basically it outputs one line and then it flops and it outputs another line. So it'll output this one over here, and then when the clock signal goes from 0 to 1, it'll output this one, and then when it goes from 1 to 0, it'll output this one. That's so it's not outputting all of it at one time and taking too much time from the actual PID calculations, so that the processor has time. I split it, on off, so it's not a big slam of information. It comes in 2 separate lines, and it smooths out the operation of the PID itself. So after 7 we have back one, sorry. That's it. So those are the basic 7 steps. I went through it really quick. I'm going to review this and see if it'll work, and go to the next part, which is the actual keyboard strokes and what they do. So let me do this. Okay, now for the keyboard commands and what they do. First off, I hope you're keeping notes, right? I told myself I'd count to 10 to give you enough time to get pencil and paper. Ready? Right on. Alright, so keyboard commands and what they do and where they are located. Let me move that. First one is your reset. Right here. That is reset. Letter R. So R. That's an R. Okay. Let's go black now. For your motor, here you have man, Eman, and morph. Man and morph. I wonder if you can make some kind of song with that. But man and morph. Capital M for motor on. Lowercase m for motor off. So that's a M and a M. Right? Alright. Now this one is here. S. It doesn't matter, capital, lowercase. That's for your set point. Right there. S. Next one, P for proportional. Should make sense to you now. I, integral. And then D. So, R, M, S, P, I, D. Those are the only ones. Alright, those are your keyboard commands. Now, when you go to update one, let's say you have all your numbers filled in and you're pretty close, but you want to change, let's say, your integral. You're at 0.01, let's say, and you want to change it to 0.0025. You want to cut it into a quarter. You want to give it a quarter of it. I just lost it for a second. Man. Oh yeah. So let's say you want to do your integral and you put in 0.025 for a quarter or the 16th of a percent or whatever the hell it is. S, if you say push the letter I, it's going to clear it out, make it a 0. Remember, so you got to put it in. Now, if you press the letter R for reset, it'll wipe everything off and turn it all off. That's kind of a panic button thing too. R is exactly what it says, dude. Reset. And then the capital M, lowercase m for motor on and motor off. And those are the only keyboard commands. And then you can put in decimals. You can put in negative numbers for your PID. Don't forget that on a PID controller you can use negative input for values, except for on your set point in Visuino. Don't put it in your set point. Put it in your PID numbers. You can use a negative number, 0, whatever, from -1 to +1. So you get the gist of it, right? All right, there you go. Let's do this then.
Hasta la vista, wiener.
Yeah, I'm taking this blade off right now. Left-handed threads. Don't leave the nut on there either. Finger, no choppy-doppy. So now you should have your project set up. You should have your Visuino file set up. You should have your project uploaded to your device or whatever you're testing. So this is the end of part 1. Getting it set up, programmed, show you what the different parts are. That way you can fiddle with it a little bit and make it work however you need it to work. So I'm going to go ahead and finish this video, get it off onto YouTube, and start working on part 2, which will be actually getting the balancing arm flying and showing you exactly how it is supposed to work to try and find your base numbers when tuning a PID, because 0.00125 might make a huge difference and you'll never know it. So good luck and see you soon.